Hello, N4H&H here. Just wanted you guys to hear that. That is an example of why I bought this Yaesu FTDX 5000. That station is a QRP SOTA station in Washington on the top of Mount Saint Helens. You can barely tell he's there. Hear him? There's some QSB on his signal. Okay, so now that you've heard him, I want to explain what I had to do to get him. I tried various antennas. I run mostly wire here, but I do have a vertical, a Cushcraft R-5. The antenna that was consistently getting him with the best signal to noise ratio, usually it's my doublet working the people out in Oregon and Washington, but today it was the ZS6 BKW. The one that I didn't build this one myself, but you can find plans online. I bought this one from ni4l.com, Chris. He just does such a magnificent job of assembling these antennas, and he uses all high quality parts. But that's how even with all the rig was doing for me, I still needed, something to work with. And that antenna gave me the best signal to noise ratio to work with. So let me show you what I had set up on the radio. I had to go to amp 2 because the ZS6 BKW doesn't have as much gain as my doublet does. My doublet's 250 feet fed with ladder line. It has a tremendous amount of gain up here. But of course that gain brings in more noise too. And so I decided to go with the ZS6 BKW. I didn't even transmit with the doublet though. I went ahead and transmitted with it as well. And therefore I had to put a little more fire in the wire. I got a 559, but I was running 1200 watts from the you guys have seen it in past videos, but there it is from the Elecraft KPA 1500. And so I was lighting up a bunch of those LEDs across the top, we'll put it that way. But, and I got a 559 to him, which that's not bad because a lot of times SOTA operators are also using, somewhat of a compromised antenna system. I'm not sure what this operator was using, but, that is the case quite often. So amp 2, and then over on this side in DSP I had digital noise reduction 15, width at 50, APF at 0. Pretty much my standard operating procedure. Sometimes I will widen the width to 100 or 150, but you see you get a little bit of that filter ring, and his signal was so weak, and that filter ring is always gonna be at your side tone frequency. So then you're having a problem figuring out what's side tone and what's filter ring. So narrowing the filter down to 50 knocks out enough of the filter ring that I could then hear his signal. And I think he's quit sending now, so I'm glad I got that into the beginning of the video so you could hear it. But that's how it was set up. Digital noise reduction 15, width at 50, and APF at 0. What I did was I just left the APF at 0, and I found him here. He was at 14.063.710. That's when my indicator showed that I was centered up on his frequency. So that's what it took to work that QRP station on Mount Saint Helens. That's a long haul. I'm not sure how many, maybe at least 2,000 plus miles, somewhere between 2,000 and maybe 2,500 miles or so. I'm going to look that up, but it was a good contact. And like I said, that's what it took. Sometimes you don't necessarily go for the antenna with the most gain. You want to go for the antenna that's receiving them with the best signal to noise ratio. So that's, you'll hear me say that a lot. I talk about signal to noise ratio. It's more important than S-meter readings and things like that. Okay, I just wanted to get that one out there real quick for y'all to see. I'm excited about that one because I've never worked anybody on Mount Saint Helens before. I've camped out one mountain over from it, but I've never been on Mount Saint Helens myself, and I've never worked anybody on that mountain. All right, thanks for watching. Thank you, Patreons, for helping me keep this going. And again, thank you for watching, and I will say 73 from N4H&H.